why is it not legally acceptable? Is it because it's literally poisonous?
They're going to drive me into a corner that I can't answer that question the way I want to.
For the hard-working souls, he raised a cheer, building a future without any fear.
So welcome back to my Timber Talk. And as you know, this is a place where we talk with experts about different subjects that are particularly focused on contracting and building. And today we have a very interesting guest, Eric Lincoln. He's at his office in Houston. And Eric, you can talk more about yourself, Eric, but I believe you've been around the lumber, timber, wood business for like 35 plus years.
33.
33 years. And that's a long time to have seen a lot of things. And you work at Building Products Plus there in Houston. Tell us a little more about yourself, if you could.
Started off as after graduating from Texas A&M University in 92 and joined two gentlemen starting a company at that time. And we were primarily in the deck and fence wood business, so did some fire retardant materials. I didn't know much of anything at the time about treated wood, and over the course of those 30 years, learned a lot about not only wood but other extended life building materials. Began to go from selling basic treated lumber to more advanced timber and really becoming a somewhat of an expert in the field of treated wood. So I do a lot of specification writing and sale and advice and try to help people.
So I'm sure. What the hell is a treatment? What is meant when somebody says, "I need my wood treated"? What's going on there?
There's several different ways that you could treat material. I mean, it could be that you're just coating it, but in the context of what we're talking about, I believe, or the context at least that my expertise is in the aspect of pressure treating. So actually taking chemical or taking wood, putting it into a cylinder, putting it under pressure, and forcing chemical through the cross section of the material.
So it goes into a cylinder, obviously, if it's going to be pressure treated. And how much of that is treated? How deep does it go when you pressure treat a piece of wood? I mean, it goes all the way through to the other side, or how does that work?
It depends on the thickness of the material. There's the American Wood Preservers Association, or the AWPA, has standards, and it generally is 80% of the sapwood or some percentage, depending on the size of the material. You get into very, very large timbers, you will only maybe get, say a 12 by 12, you might only get 3 inches of material that you get cross-sectional, that you get treatment, but maybe in a 2 by 4 you'll get total cross-sectional penetration.
And so do you treat the log before you cut it, or you treat the log after you cut it?
So you're treating finished material. What you're treating is the product that ultimately will go to the customer. It's a gradient of chemical penetration. On the outside of the wood, you have the highest level of penetration. As that chemical is going into the wood, you have a decreasing value of.
What would you say what are some of the reasons or the primary reason to treat wood at all? Why do this?
To extend its life. That's it, 100%.
What do you mean extend its life?
Well, to extend its life, when we are talking about conventional pressure treatments, what people would say, the most common term that people understand is like womanized wood. That's an old term that people would say and use. That is for outdoors or areas where rot is.
So it extends its life by reducing rot.
There are other types of pressure treatments, such as fire retardants and such like that. But primarily, if you're saying pressure treated, people are referring to extended life.
And so what causes the rot of a piece of wood, of lumber?
Can be a few things. You'll hear people use the words dry rot, which is usually fungal decay. The root structure breaks down breaks down the cells of the wood and causes it to basically delaminate. That's one type of rot. You have organism rot where termites or whatnot are eating the wood. They're consuming it. And then in saltwater environments, you can have different types of organisms, a Turrida limnora, organisms that will actually dig holes in the wood and use the piece of piling or what have you as a living quarters. So they're not actually consuming it. They're just drilling in.
That's incredible. So obviously the same treatment doesn't apply to all of these things, dry rot versus no.
You have basically 5 levels of chemical as defined by the AWPA, and it's called the user code system. It's UC1 through UC5, and then there's subcategories under each one of those. And those go from just a basic treatment like you would have plate stock in a house, like what the bottom piece of wood in a wall that goes on the concrete, that's treated, and it's a very minimal level treatment. In some cases, it's a chemical called borate.
So when you say minimal, you mean it's only close to the surface?
Not necessarily. It's not necessarily so you have to break those two things apart. You have penetration and you have retention. So penetration is how far the chemical goes into the wood, and retention is how much chemical you're putting in the wood. And then inside of that, you have different chemicals for different applications. So a borate, which is used as a chemical for like plate stock in a wall or interior applications, maybe under an area where there's a high likelihood of water, like a water heater or something like that. You might use borate treated wood. That's one type. But then you get into the MCAs, the CAs, the CCAs. These are different chemicals that have a whole range of retentions and penetrations associated with them.
So as I look at my notes here, I'm wondering what are some of you mentioned one application, as you say, inside the house, but what are some of the other major applications for? I've heard MCA, CCA a lot out there. What is the different what are the different applications for those?
So let's unpack that by treatment duty. So you might have low conditions such as playground equipment or something like that. Landscaping, I guess, would probably be the lowest, like raised garden beds and such. That's
you mean lowest actually in terms of altitude from other?
No, not altitude so much, or not necessarily distance, but consequence, maybe.
I think if a garden bed piece of wood falls apart, it's not a big deal.
Exactly. Yeah. So you have
criticality.
That's a better word. Yeah, that's a more useful word. So you have something like garden beds, then you can have like steppers or walkways or things like that are not that they don't, you want them to last, but they're not as critical as such a thing as a house piling where it's structurally critical. It bears the weight of the home itself.
And so the different types, MCA, you'd use MCA for all of that?
No, you wouldn't. MCA and CA are chemicals that don't have chromium and arsenate, which are deemed as
poisonous.
Carcinogens is what and then they don't want them used in contact areas. So
contact with humans, you mean?
Yeah, exactly. So there are areas where you have to use something like a CA, which is copper azole, which is deemed as a completely inert chemical that won't hurt people by touch or anything like that.
So, I'm sure you have come across just probably in your time hundreds of misuse applications for treatment where they had one treatment. And one you could talk about maybe is one recently that I heard you talking about, which you mentioned, which was at a zoo or something where they used MCA and the expectation was that it would last 7,000 years, but it fell apart after a while.
MCA and CA both, the copper azoles they're deemed as the safe chemicals, but their longevity, their rot resistance is not proving out over time to be as effective as people thought they would be.
So what's the alternative to them? CCA?
No, you can't use CCA in those applications. In this specific application that you're referencing about this zoo, this was a bridge, and it was substructure underneath a walking bridge. And so they used MCA, and the MCA failed. And in that application, you can use CCA. Now, CCA has been around, I think, since 1920s. And it has a very, very long history of being used from everything from telephone poles to you name it, and is an extremely effective chemical and works very, very well.
So give the viewers some indication of time. When you say longer or shorter, are you talking months, years, decades? What's some of the time
So
idea?
time is tied to application, 100%. You take CCA and you use it in a bridge application where it's above ground, it's not submerged in water, it's strictly a structural beam or something along those applications, and it wouldn't be unusual for that to be structurally sound 50 years from now. So that's one way. You take that same piece of wood and you put it in water, and depending on where you are in the US and depending on the type of water, you might see 20 years, you may see 10 years. So the US is divided into zones. There's 5 zones. You have a coastal zone that goes like from Florida around to Texas, and that's considered extremely high rot.
Up the East Coast as well, probably, yeah.
Actually, no, it breaks off. It's climate defined. So by being in a warm climate like that, the potential for rot is more year round. There's no freezes. There's nothing to stop the plant life. Or so the further you go north, you get to zone 2 and 3 and 4 and 5, all the way up in the cold belt. You'll get a much longer lifespan out of the same piece of wood, out of the same exact treatment, just because the organisms that exist and defreeze.
I would also imagine the species of wood would give you a completely different time span, southern yellow pine versus oak versus whatever.
So there really is only 2 species of wood that are being pressure treated with these water-based chemicals, and that would be primarily the pine trees, different kinds of pines. There's lots of different kinds of pines. Primarily southern yellow pine is the largest. And the benefit of southern yellow pine is you have connecting cells. So you get cross-sectional penetration without doing anything to the piece of wood. So that piece of pine will accept chemical all the way through without doing anything. The other major piece of wood that people use that they treat is Doug fir. And Doug fir, you have to do something different. You have to actually incise that piece of wood to get that longevity.
I was going to ask about that because incising is basically when you go to like a Home Depot, you see all these little holes in the wood.
Yeah, so this is a piece of Doug fir.
Don't move it around so much. Oh, there it is. Yeah, you can see all these holes.
Those are the incising marks, and this is a borate, and you can see that the chemical penetrates that wood where those incising marks are.
And doesn't go much beyond that.
It doesn't go beyond that at all. This piece of wood would be ineffective in the southern zone. In that zone 1, that critical zone, this would never hold up. Whereas you have a similar chemical, here's the cut side, of southern yellow pine, and you can see that the chemical is all the way through that structure. So there's no incising marks. That's just the piece of wood as it stands, and it penetrates the wood as it is.
Why are some pieces of wood, when I look at them, green and some are brown and some are yellowish, and all of them have been treated?
Different chemicals. So CCA, which is the chemical, the 3 chemicals that we see the most of. There are lots of chemicals, and there's new ones coming out, DOCI and all these other things. There are 3 chemicals that we see, and I'm going to speak for the South because that's really where I do my bidding mostly. We see MCA, CA, and CCA. CA and CCA both have a green color to them. That naturally, as they come out of the cylinder, they have a green hue. MCA is brand named yellow wood, and it has a much lighter color.
So as a contractor, and I'm going to build a house, and it's in a marine area. I don't know what area you call it, but it's along the coast. It's in Louisiana, or it's in Texas or somewhere like that, maybe Florida. My biggest concern is what? Exposure? That's what determines the amount of treatment? Pressure treatment?
Exposure.
Of the wood. So if the wood is inside the house in the walls, you don't treat it.
You don't treat the most of the frame. You generally treat the lowest part, which is in contact with
the
slab,
plate.
which is called the plate.
But if it's not on a slab, if it's on a piling up in the air, you wouldn't even treat that because then that's sitting on stringers, right?
Different people will do different things in that application depending on whether they're going to put. Sorry.
plywood or
Yeah,
rubber.
like soffit material or something over the top of it, they might not treat it, but there are a lot of people that will treat the piling and they'll treat their stringers and even sometimes the joist. I've even
So
seen
who specifies all this? I'm a contractor. I'm going to build a house for somebody, my customer. Who selects the treatment at various levels? The treatment for the pilings or for the inside or for the gateways or whatever. Who does that? The contractor? Or
contractors generally choose. However, I would say that there's general construction practices that have been accepted across the board for applications. So most contractors understand that CCA is a very tried and true chemical, that it's acceptable to be used in
water
those applications, not even water, but in substructure. It's called,
substructures?
yeah, it's called permanent wood foundation
Mhm.
as in part. And in those applications, you would see CCA used primarily.
So I had a couple more questions as I was looking at my notes here, and one of them was, can you think of any common misconceptions if I was a new contractor coming in or a homeowner that had some ideas? I don't want this or I want that type of treatment. Are there any common misconceptions out there that
A lot, yeah, a lot. One, that all treatments are the same, not understanding the difference between penetration and retention, which could be a talk unto itself, but it's detailed in more.
retention again is how much material, how much chemical you're going to use, and penetration is how far it goes into the wood?
Yeah, it's where you rate that retention. Yeah, exactly. The
Sorry to interrupt.
around longevity.
Sorry to interrupt, but retention, how is that determined? In other words, they literally crank up the pressure to get it to penetrate more,
Yeah.
or they literally put in more chemical to get greater retention?
In its simplest form, I'll give you a 30-second breakdown on the treatment process. You start with the wood, it's put on trams, it's put into a closed cylinder that can be completely sealed off. It's a controlled vessel, steel. You start by drawing a vacuum. You remove all the air from that cylinder. You then flood that chemical into that cylinder. So the cylinder becomes completely flooded with chemical. You then release the vacuum, and the wood has compressed under a vacuum, and the very first thing it does is expand, like you've stood on a sponge and then you step off of it, and it absorbs a whole bunch of the chemical. So that the mass majority of the chemical that is going to be accepted happens at that point. However, for the next hour, you will hour 15, hour 20, just depending on how the wood receives it, you will increase and decrease the pressure to push the chemical further and further into the wood.
So
Once you're done,
depending on
the loose chemical, and then you take the wood out of the cylinder.
so depending on who determines then the intensity of that one way or the other? Do
The
they
way it's
literally
worked-
just make a whole batch of it at one level of intensity and then make another batch at another level and sell those two as two different products? Is that how they do it, or do you order it?
The way you order it, yeah. The way you order it, you will specify the chemical, you'll specify the retention, and people don't realize that they are also specifying the penetration. It's application driven. So a house piling is a different penetration than, say, a board.
So I hear the terms 1.5, 0.6, 2.5, all these points and all that. What is that?
Those are your retentions. Those
And
are your retentions. So 0.6 is 0.6 pounds of chemical per cubic foot of wood.
And so when somebody says, which you hear all the time, house piling 12 by 12, 2.5, means they want a retention of 2.5 CCA on a house piling so that it can take rain and wind and water and everything else and last for 25, 30 years.
And you just dove into the first major misconception, which is that 2.5, which is a chemical that is really reserved or is needed in a saltwater environment, and it's needed in an open water saltwater environment. So
That's
not
right.
just water that's salty, but rather actually in the ocean is the
Because the ocean has movement and stuff, right? Whereas other water
it has a different set of organisms. It has the Teredo, Lenora, the Formosan termite, these organisms that exist in saltwater that do not exist on land, that do not exist in groundwater. There's people that say, I like overkill. I like to do things. You don't really benefit by going to 2.5.
because it's only for saltwater environments. Yeah. Yeah, interesting. And what are the costs like from treatment to treatment? Is there a major gap between CCA and CA and MCA for the consumer, for the contract?
User code standard. So at the same, there's another misconception is that, that the as you said, the 0.14, 0.15, those relate equally across, like you would use that same nomenclature for CCA, and that's not the case. Each chemical has its own
Retention rates.
retention number per se. You would miss you're back to I drove myself off the question. Good
But that's the cost, so the cost variance.
Okay, so the cost variance on the same level of user code standard, they're fairly similar in price. So in other words, in a light setting, say a fence, where you're going to use something like a 0.40 CCA, which is equivalent to say a 0.14 or 0.15 in the copper azoles, those chemicals cost about the same.
And then, but what's the gap? Is it like, and how do you pay for this? Per foot? Per square foot? Per linear foot? How do you pay for it? By the board. And so the difference, if I took the same piece of 2 by 20 and I made it MCA, what's the wild ass guess gap between an MCA 2 by 20 and a CCA 2 by 20?
If the application is, if they're being used in the same application, so the retentions are supposedly equivalent,
right?
0.
So pressure treating is really and totally application based.
Application based.
Yeah. Well, I can't think of too much more except that the contractor really needs, I guess contractors get accustomed to what they use and they use it again and again, so they don't think too much about it. It's like a 9-penny nail, they just use it. But the point is there are many options, right?
There are, and CCA has the longest history, and in my experience, has the greatest resistance to rot and decay. We see the greatest longevity associated with CCA. So we really encourage people to use CCA where it is legally acceptable.
Why is it not legally acceptable? Is it because it's literally poisonous?
You're going to drive me into a corner that I can't answer that question the way I want to.
Is it detrimental to human skin?
On December 31st of 2003, there was a voluntary removal of CCA from specific applications as it relates to human contact. So
really?
That would include not using CCA in playgrounds, picnic tables, any area where there is a direct human contact.
Interesting.
CCA has never been not allowed to be used in areas such as saltwater because there is no chemical retention that is equivalent to a 2.5 CCA. And again, this is all around pine because fir has AZCA and they have their own chemicals, and there's oil-based chemicals. There are other things that are not specific to this. But in CA and MCA, there are no equivalents for 2.5. In the areas where, say, 0.60, which is a foundation treatment for timber, for square timber, you wouldn't use CA or MCA. They just don't tend to have the same resistance.
So in other words, a piling for a house and you're going to build it up 12 foot off the ground and you use MCA, you're just asking for trouble after 8-10 years.
That's a critical application and you wouldn't want to use CA or MCA, in my opinion.
So when I see these big trusses, and I have a couple here in this room actually, when I see these big trusses, are they treated?
They can be. Typically, they're not. There are a few times where they may get rainwater that sits on them or something, like in an open pavilion or something where somebody might want to. High humid areas, maybe in Louisiana, where there's the potential for molds and mildews and things like that, where somebody might want to use a treated. Yeah. And in that case, they can absolutely be treated. You can treat any piece of pine, you can treat it for any application.
Well, that leads me into a request that you come back and spend more time. Next time we'll talk about trusses, because I believe you have a lot of experience in that. When I did research on you and know you for a few years, that's really one of the areas of expertise you have. And so we could talk about
one of my favorite things to talk about.
Yeah, definitely one of the other things. Thank you very much, Eric, spending the last half an hour with us.
Anytime.
And let's let's get back together again on that.
You
But
got
thank you, everybody, and thank Eric. And you can click on the subscribe or like or whatever.
If you have a specific question about treatments, what kind of application,
Put
where
it
it
in,
should be,
put it in the comments below.
put it in the comments below, and also feel free to give us a call on the company.
What's the best number for that?
That'd be 1-800-460-8627 is our company line.
4608627. Thank you. Or what's your email address?
Eric, ERIC, at mytimber.com.
Thank you very, very much, Eric.
Anytime.
Bye.